This lesson is on the dissociation of acids and bases. Okay, is how do they split up into ions? In aqueous solutions, acid and bases will split into the respective ions. So you should have this sheet in front of you right now. Dissociation of acid and base. Okay, they'll split into their ions. If it's a polyatomic ion, it stays a polyatomic ion. So the first one here, HClO4. HClO4 will split up into hydrogen and hydrogen plus and plus ClO4 is the ion, so that's how they will split up. Okay. And as far as how do they split up, there is a list of on the next page for you of strong acid and bases. Strong acid and bases are these: perchloric acid. There's only 6: perchloric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid. And then you have 6 strong bases: lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide. And these are strong acid and bases because they dissociate completely. Dissociate completely in water. Okay, so they are very strong. They add a lot of hydrogens to the aqueous solution. And so the next one here, H2SO4, this will split up. What's going to happen to H2SO4 is going to do it 2 times because there's 2 hydrogens. So the first hydrogen is going to split up into H plus H. We lose an H there, so it's SO4, and it's going to be minus 1. And then it's going to happen again. This is a special case. We're not going to deal with a lot of diprotic, which is 2 hydrogen acids here. For our purpose in pre-AP chemistry, we're just going to focus on a lot of the 1 hydrogen acids, okay? So this is a special case here. And then HSO4 will go and do now this acts as a weak acid. It's going to go and do that one more time, H plus SO4, 2 minus. It's going to do that, okay? And you'll see that this double arrow here indicates it's a weak acid because it can reverse. The reaction is reversible for weak acids. And so C, HCl, will split up into 2 ions, which are, it's a strong acid. It's going to split into H plus Cl minus. Okay. And then D, this is not a strong acid. Acetic acid is not a strong acid. It's not on this list of strong acids, which you should check every time. Is it a strong acid? You ask yourself that. It is a weak acid, so you have this double arrow going to H plus and then plus acetate ion, C2H3O2 minus. And then HNO3, check to see if it's strong acid. Strong acid is 1 arrow. HF, check to see if it's strong or weak acid. And so you do these 2, and then we'll continue on. Then the next one, number 2, bases here. Write the equation for dissociation of following bases. The same thing. It's going to split up into the positive part, the K plus the OH is what makes it the base, 1 OH there. And so you look at the strong acid, strong bases here. If it's a weak base, you draw the double arrow. Okay, so let's check. NaOH strong. NaOH strong as well. MgOH2, this is weak, so you have the double arrow. BaOH strong. LiOH strong, so you only have 1 weak there, so you have that double arrow on that one. Okay, so that's how acid and bases split up. And then so now, if we know how they split up, we know how many hydrogen ions and how many hydroxide ions, and we can calculate for the pH, pOH. And so that should be a review here. But so number 3, we're going to combine a bunch of stuff from what we've learned in the past. So number 3 here, a solution contains 0.635 grams of NaOH in 236 milliliter of solution. Write the equation for dissociation of NaOH. We already did it earlier. NaOH will split up into Na plus plus OH minus. Okay? And so the question is, how many moles, what's the molarity of the NaOH that we start with? Molarity is concentration. Remember, molarity equals concentration. Concentration is the capital M. Okay? And we need to find that concentration of NaOH so we know how much concentration of OH is. And when we know the concentration of OH, that's this right here, the OH concentration, we can find the H plus concentration, and we can also find the pH. Okay? So we have a mass and a milliliter. To find the concentration, we need moles. Remember, concentration is moles over liter. We need to find the number of moles, but we have grams. So what do? Get the periodic table, get the mass of NaOH, which is 40. So we change that to find molarity, so B here, so 0.635 grams of NaOH. Change that to mole, so 40 grams of NaOH is 1 mole. Get a calculator here. What is this? 0.635 divided by 40, enter, so I get 0.0159 mole. Okay, I always keep 3 numbers that's not 0. See, that 1, 5, and 9, that's not 0. Because these are small numbers, you don't want to round too much. Divided by, it's 236 milliliter, I need to change that to liters. So divide by 1,000, I get 0.236 liters. Now I take that, find molarity, divide by 0.236, enter. So my molarity is 0.0673 molar, right? 0.0673 molar of NaOH. Okay? So this NaOH, remember, it splits up completely. It's going to break up into the same amount, 0.0673 molar of Na and 0.0673 molar of OH. And that there, ladies and gentlemen, is what we need. That right there. We have the concentration of NaOH now. So the concentration of NaOH is 0.0673 molar. Okay. And so how do I find the concentration of H plus? Remember, OH, H plus and OH is equal to 10 to the negative 14. So basically I take 10 to the negative 14 divided by OH to get my H plus. We've done this. This is a review. So 10 raised to the negative 14 divide by OH, which is 0.0673. Enter. So I get 1.49 times 10 to the negative 13 molar. That's my H plus. Okay. And to get the pH, pH is equal to the negative log of that, 1.49 times 10 to the negative 13. And I will get the pH of that. Negative log of, how do I enter that? Where's the answer? Here's control answer. It'll just input that last answer into this. And I'll hit enter, and I get 12.8. Just about 12.8 is my pH. And that makes sense because look, NaOH is an acid. It's a strong acid. So a pH of 12.8. 12.8 is what? Acid or base? Base. Very good. Yeah. So that is 12.8 for your pH, and that's how you do that. Okay. So recap. First of all, I changed the mass to mole. Change the milliliters to liters to get the molarity. That is the molarity of the concentration of NaOH. It splits up into one OH. So then you have to just basically copy it over. The same concentration. And then that's your OH. You can find the H plus here. This is your OH. Okay. And then you find your H plus concentration there. And then you can find the pH. Okay. So if it's the acid on number 4 here, you will find the H plus concentration from the concentration that you find in part A. Okay. That'll give you the H plus. And you do number 4 and number 5. Okay. That concludes it for this sheet. I'll make a video for the next sheet. Goodbye.